Hello friends, today I will discuss about how to check different current, that is transformer HV current, LV current and transformer differential current and also the bias current in ABB make RET650. Before going through this video, you are requested to please go through my channel and do subscribe my channel if not subscribed earlier, and also press bell button for notification of videos to be uploaded in future. To check different current in ABB make RET650, you have to go through the measurement option in the first page. Then if you go through the measurement option and click the right arrow, a page will be open. In this page there will be two options to see the different values in primaries. You have to go through the analog primary values. Again, three options will be given. In the second option, if you press the right arrow, then again a page will be open. In this page there will be the primary values of the HV side current and LV side current will be shown. Now HVCT, IL1, IL2, IL3 are the red phase, yellow phase and blue phase current respectively for HV side current, and LV side CT, IL1, IL2, IL3 are the red, yellow and blue phase current respectively for LV side. The values of the current are shown here. Now go through the previous page. Again press the left arrow and then again the previous page will come. Then press the left arrow again, the first page will be appear. Now we want to check the different differential current and bias current. So you have to go to the test option in the first page. If we press the test option, again a page will be appear. In this page there will be different option. You have to go to the function status in this page. If you press the right arrow button on the function status option, then again a page will be appear. In this page there will be different option. We have to go to the differential option in this page. So again in this page you have to click the T3W, then again a window will open. Again click it or press the right arrow, and then there will be two options, input and output. You have to click the output option, and then in this page again a page will be open. In this page you have to go to the scroll down to the scroll down, so that at the last you will get the different differential current and bias current of the transformer. Here IDL1, IDL2, IDL3 are the red phase, yellow phase and blue phase differential current which are referred to the HV side, and the values are 0.45, 0.526 and 0.509 ampere, and I bias current is the maximum of the HV side current, that is 49.950 ampere. Now how this currents comes, we will calculate in details. So before calculating the different current, first we have to go to the settings option, that is the connection type. Here W1, that is HV side winding is Y connected, and connection type, that is W2, that is LV side winding is delta connected. Again W3 is given, which are not necessary, it is a two winding transformer. The clock number for W2, that is LV side winding is 1, that is it is YN D1 type, and it is LV side winding is 30-degree lag of that of the HV side winding. Now there are different settings is given here which are not required, but the differential current for characteristic, that is ID minimum, end section 1 and end section 2 and end section 3, the different slope has been given in this setting. Now we want to calculate the differential current and the bias current by means of the this connection type of the transformer. Here different current for HV side and LV side winding are again summarized here. That is red phase, yellow phase and blue phase winding for HV side is 48.566 at an angle of 0 degree, 48.710 at an angle of minus 118.746 degree, 49.035 at an angle of 119.963 degree respectively. And again for LV side, red phase, yellow phase and blue phase currents are 197.2 at an angle of 149.773 degree, 195.728 at an angle of 30.782 degree, and 199.022 at an angle of minus 89.441 degree. The differential current is again summarized here. That is for red phase, yellow phase and blue phase, the differential current are 0.657 ampere, 0.657 and 0.370 ampere respectively, and bias current is 49.974 ampere. So we will calculate in details differential current and the bias current. Bias current is nothing but the maximum of HV side current. So there is no calculation required for bias current, but the differential current calculation is required to match with this summarized value. The equation for differential current phase wise is given in this figure. In the first option in the left hand side, the IDL1, IDL2 and IDL3 are the phase wise differential current in HV side reference winding, and HV side in the right hand side, the HV side current are multiplied by the factor or matrix A to nullify the zero sequence current in the HV side. If it is a delta current connected winding, then the value of the A matrix will be different of that of the with zero sequence filtering. And now in the second part of the right hand side of the equation, there is a ratio. Ratio is nothing but the LV side face-to-face voltage to the HV side face-to-face voltage. It is multiplied to the value of the B matrix into LV side line current. The ratio is multiplied in order to convert the LV side current in the common reference value of the HV side current. Now the value of the B matrix is such so chosen that it will nullify the phase shifting due to the vector group of the LV side. And IL1, W2, IL2, W2, IL3, W2 are the LV side line current. So now I will calculate the different value of the phase wise differential current one by one. In this matrix equation, the value of the A and B has been given, and the value of the phase wise red phase, yellow phase and blue phase current for HV side and LV side is been given in this figure, and even underscore W2, that is LV side face to face voltage and HV side face to face voltage is given. So the value of the red phase differential current, that is IDL1, is given by IL1 W1 plus 33 by 132 into 1 by root 3 into IL1 W2 minus IL2 W2. Now since IL1 W1 is equal to 48.566 at an angle of 0 degree plus 0.25 into 1 by root 3 into IL1 W2. This value is 197.2 at an angle of 149.77 minus of IL2 W2, the value of which is 195.73 at an angle of 30.78. So simplifying this equation comes as 48.566 at an angle of 0 degree plus 0.25 into 1 by root 3 into 338.543 at an angle of minus 179.85, which comes as equal to 48.566 at an angle of 0 degree plus 48.866 at an angle of minus 179.85, or you can say which is almost minus of 180 degree. So this two phasor is almost equal and opposite in phase. That is why the value of the IDL1 is close to 0, that is which is approximately equal to 0.3 ampere. That is 48.566 minus 48.8666, which comes as 0.3 ampere. Similarly, the value of the IDL2, that is yellow phase differential current in respect of the HV side winding, is calculated by the equation is IL2W1 plus 33 by 132 into 1 by root 3 into IL2W2 minus IL3W2. Now value of IL2W1 is 48.71 at an angle of minus 118.75 degree plus 0.25 into 1 by root 3 into IL2W2, which is 195.73 at an angle of 30.78, and IL3W2, the value is 199.02 at an angle of minus 89.44. So simplify it, which is comes as 48.71 at an angle of minus 118.75 degree plus 0.25 into 1 by root 3 into 342.246 at an angle of 60.944. By simplify it, we will get 48.71 at an angle of minus 118.75 degree plus 49.4 at an angle of 60.944 degree, which comes as 0.7377 ampere. It is the value of the yellow phase differential current in respect of HV side current. Similarly, the blue phase differential current with regard to the HV side winding is calculated by the equation given by IL3 W1 plus 33 by 132 into 1 by root 3 into IL3 W2 minus IL1 W2, and the value of the all IL3 W1, IL3 W2 and IL1 W2 is put. So the equation comes as 49.35 at an angle of 120 plus 0.25 into 1 by root 3 into 199.02 at an angle of minus 89.44 minus 197.2 at an angle of 149.77 degree. By simplify this equation, the value comes as 49.35 at an angle of 120 plus 49.725 at an angle of almost minus 60 degree, which is equal to 0.375 ampere. So the value of the blue phase differential current is 0.375 ampere in respect of HV side reference winding. So this is how the differential current of different phase is calculated for ABMAC RET650